So now the last thing we'll talk about in this section is the transpose of a matrix. So if you have an m by n matrix, pretty general, right? The transpose of that matrix, well, first of all, the notation that we use, you just put a superscript, kind of like an exponent, but it's not an exponent. It's just you put a capital T as a superscript. So that indicates that you're not talking about A, you're talking about the transpose of the matrix A. And what is the transpose of the matrix A? Well, first of all, its dimensions are given by n by m. Notice the dimensions have been flipped here. A was m by n, so the number of rows of A is the number of columns of A transpose, and the number of columns of A is actually the number of rows of A transpose. And essentially what you do is you just kind of fold the matrix over, right? So what you're going to do is you take all the columns of A, and instead for A transpose, they're now going to be the rows. Or equivalently, it would work just as well as if you said, okay, well, I'll take the rows of A and I'll rewrite them as columns for A transpose. You could take either approach and you'll get the same thing. Or if you want to talk about one entry at a time, this is the formula you can use. You can say, okay, if I want the entry from A transpose that occupies the ith row and the jth column, well, by definition, so I'm just saying this symbol, by the way, I can't remember if I've mentioned this before, this just means is defined to be. So whatever I put over on the right-hand side, that's the definition of this quantity. And if I can just, that's enough to define transpose, right? If I can define a rule that tells you how to compute any particular entry of A transpose, well, that's enough to define A transpose. Okay, well, what is the definition? Just take the entry from A that occupies the jth row and the ith column. Notice I've flipped the indices here. Okay, and this is a rule that is valid for each I from 1 to all the way up to n, and each j that starts at 1, 2, and goes all the way up to m. Really, what are we adding this for? Just to make sure that I and j are reasonable pointers to rows and columns of the matrix A transpose, right? Because if A transpose is n by m, it's got n rows, so the row index better be between 1 and n. And if it's got m columns, well, then the column pointer better be between 1 and m. So that's all that's going on there. So that's the formal definition of transpose, but in practice, it's very straightforward to take the transpose of a matrix. Let's look at a few examples. So here we've got a 2 by 3 matrix, and we want to take its transpose. So the result is going to be a 3 by 2. And all I need to do is just take the first row and write it as the first column. And then I'll take the second row here and write it as the second column. So 0, 2, negative 5. That's all there is to it. That's all you have to do for transpose. Let's look at another example. Here we've got a 2 by 2 matrix, and we're taking its transpose. So the transpose is going to be 2 by 2 as well. What did I do? Last time I took the rows and rewrote them as columns, right? So this time, just to be different, I'll take the columns and rewrite them as rows. So the first column is 1, negative 2, so I'm going to write it as the first row of the transpose. And the second column is 8, 7, so I'll write that as the second row. And that works as well for getting the transpose. Okay, and here we've got the transpose of a column matrix. But notice, what if I wanted to view this as a vector, a column vector? Well, that's fine. I can still take its transpose, and I would just get the same vector, but expressed as a row matrix. Remember, you can express vectors as either row matrices or column matrices, depending on which is convenient for the time. The transpose gives you a way to convert from column vectors to row vectors, or vice versa, from row vectors to column vectors, without actually changing any of the entries. But we don't need to worry about vectors at the moment. We can just say, okay, this is a 3 by 1 matrix. So the transpose is going to be a 1 by 3 matrix consisting of 1 row and 3 columns. So the first column is going to be the first row of the original matrix. The second column, 0, is going to be the second row. And then the third column, negative 7, that's the third row of the original matrix. So that's a few examples of transpose. But transpose is a very straightforward operation.